All right, welcome everyone. Good afternoon. I would just suggest we wait, 1-2 minutes more, and then we can start our event. All right, it's 2 minutes past the hour. So I would suggest we kick this off. So good afternoon, everyone. Hope you're doing well. Welcome to the second edition of our SPE Special Geothermal Talks event series. So this is a joint event organized by 10 SPE sections, SPE Romanian sections, SPE Vienna Basin section, Italian section, Spain, Turkey, Croatian, Copenhagen, Netherlands, London, and Central Ukraine section. So thank you to each and every one of you for accepting this invitation. So we have registration for today's event from 24 different countries. My name is Ákos Kiss. I'm here on behalf of the SPE Vienna Basin section, and I will be moderating today's session. But first, I would like to introduce Gabriel Krubak from SPE Romanian section, who is the founder and the father of this event series. So I would like to ask him to speak a bit about the special geothermal talks.
Hello, everyone. Good afternoon. Thanks a lot, Ákos. We're glad to be here today. We know it's a day after the festivities, so highly appreciated. There's going to be a great topic going on. One thing that we wanted to do before we go ahead is you're going to see a poll launched. If you don't mind answering to it, it's going to give us a little bit of an idea of if you have heard of what the special geothermal talks are. Essentially, it's what Ákos was talking about. Is we see the importance and the value of this source of energy across Europe and beyond. And so what we try to do is to bring sections together, everybody equally contributing to this event and this effort, and trying to educate more the public, whether we are in the oil and gas or beyond, about what the opportunities are, how the future is looking like, and what do we do to work together and make this happen faster in an economic and a sustainable way across different geographies, let's say. And we believe that this kind of event like geothermal specials will help us do that. As I see on the poll right now, I'll share the results. Looks like 50% of you have heard about the special geothermal talks, 48% no, so 52-48 right now. Essentially, what I wanted you to know is that there will be an event per month of each section. So we had started with the Romanian section. The Vienna Basin is doing one for this month, and it's a great, interesting topic. We're going to transition in May with SPE Netherlands, and we'll be covering more on the flow assurance side in terms of geothermals, injection and production. In June, we're going to have an exciting presentation from the Croatian section, and I believe the main presenter is on this call. It's great to see you here, Mr. Dragutin. And we're going to try to understand what the geothermal situation is in Croatia. Then we'll move on with SPE Spain as well, talking about the repurposing of oil and gas wells. How do we do more with what we already have faster? And then the central Ukraine section will be covering a session in September. So be on the lookout for these posts on LinkedIn, on emails. Invite those that are around you. We believe that they're of great value. Without further ado, I'm going to leave it to Ákos and Werner. And thank you so much for everybody being here and to everybody supporting this event. Thank you.
Thank you very much, Gabi. So let me introduce you our special guest for today, Werner Donke. So Werner Donke is founder and partner at Greenwell Energy, CTU, Subsurface Engineering. So he studied petroleum engineering at the Mining University in Leuven and started his career in 1997 at Halliburton. He held several senior positions in business development and operations management across Central Europe. After he left Halliburton in 2016, Werner joined forces with Robert Philip to find an economic way to upcycle existing depleted oil and gas wells to give them a second life by producing geothermal energy. In 2018, they founded Greenwell Energy together with Acetila Köstinger. So thank you, Werner, for accepting this invitation and welcome. By the way, Werner joins us from New Zealand, so it's around 11 p.m. now over there.
Yeah.
So additionally, if you have any questions, please don't hesitate to type on the chat, and then we will answer them during the Q&A session. So please participate. And the event is recorded, so you can watch it again later. So Werner, please go ahead.
Good afternoon. My name is Werner Donke, and I'm one of the founders of Greenwell Energy GmbH. I'm very thankful and appreciate the opportunity to talk today about Greenwell and what we do in respect of upcycling of hydrocarbon wells. So for those that have not yet heard of Greenwell, what are we doing? In short, we deliver green heat from depleted oil and gas wells to innovative agripreneurs. So this is innovative entrepreneurs in the agricultural sector. Just to get started, we see energy consumption as an opportunity. Everybody talks about energy, especially since last year. But what is usually meant by energy is rather electricity. But as we all know, energy doesn't just mean electricity. Electricity is just about 20% of the total energy consumption. Heat, however, accounts for roughly 50% of the total. If we look then at the electricity itself, for example, in Austria, we do see, or often we don't see, that the majority is already coming from renewable sources. So Austria is roughly about 75%. However, with respect to heat, the situation is completely different. Only about 40% comes from renewable sources. And that differs across Europe and the globe, but it's in that range. So we have a huge need for renewable heat, and that need is growing. The last months show us the relevance of energy supplies and highlighted that it's not only electricity, but also heat for which we need renewable sources. So on the other hand, there is a growing trend towards regional and local production of agricultural products, especially after the supply chain disruptions due to COVID. Innovative products like shrimps, watermelons, or ginger from Austria are not that exotic anymore. That's all being now produced in Austria in limited quantities already. But how can we cover the year-round demand for those organic products if the cultivation should be done locally without imports from, for example, Spain? Currently, mainly glass houses are used, and those are heated with oil and gas, in the best case with biomass. Most of us eat strawberries or tomatoes around the year without giving much thought to it. But we all know, or at least should know, that they don't grow in Central Europe in January. So there is an energy source that we all know too well, hydrocarbon wells. About 800 wells produce oil in Austria, 85,000 in Europe, and more than 2 million globally. In addition, there are hundreds of thousands of gas wells. After years of producing oil, they will be liquidated by the oil companies, and one can't use them for anything anymore. This is a treasure in our garden, literally, as most wells are situated in zones of pasture land. In Austria, oil and gas are produced mainly in two provinces. One is the Vienna Basin. It's located northeast of Vienna and extends into the Czech Republic and Slovakia. The other one is the molasses zone, and it begins west of Linz and extends through Salzburg to the Munich area. Not only in Austria, but across Europe, we are in the fortunate situation, sorry, got stuck. We are in the fortunate situation that the hydrocarbon wells are usually not far away from metropolitan areas, such as Paris, Munich, a couple of cities in northern Germany, Bucharest, and others across Europe. Therefore, it's not a long way from the energy sources to the areas of demand for the products grown using that energy. So these wells can be used to generate geothermal energy. How is it done? Usually for a deep geothermal loop. Well, technically, it's quite simple, as most of you will already know. You first drill a deep well. A cool fluid is pumped into the well and gets heated by Mother Earth. The hot fluid returns to surface and is used in an endless cycle to heat, for example, a greenhouse. The drilling alone is more than 90% of the well costs. This means a couple of millions of euros have been spent already by the oil company. By reusing depleted wells, we avoid these costs. So how do we at Greenwell use these wells to generate geothermal energy? Our solution is simple. We take an existing well. The bottom will be plugged off so that oil or gas cannot enter the wellbore anymore. Only heat enters the well, and this heat is sustainable, safe, without CO2 emissions, and without any significant operating costs. But why isn't that done already on a large scale? Well, oil companies have a different business model. They just aren't really interested in it because their business is oil production, and that's fair. And that is also much more profitable. And why isn't a farmer doing this? Because you need special skills to successfully implement such a project. So this is our mission, to establish geothermal energy as the energy of the future, bridging the gap between oil companies who no longer need their wells and innovative agricultural entrepreneurs, so-called agripreneurs, who need heat to grow their produce. At Greenwell, we are a unique team of founders that combine different skills and expertise to complement each other. Robert is an environmental engineer, Acetilo's strength is in marketing, and I started as a petroleum engineer. We have extensive experiences around the oil industry, but also agriculture. How do we make a product out of such a depleted hydrocarbon well? First, in the scouting phase, the oil company supplies with lists of the wells to be liquidated. From these long lists, we identify those wells that are technically, ecologically, and commercially viable. We then model the individual wells to see what is the geothermal potential and for which application could they be used. If we decide to take on a project, we buy the land, we take over the well, convert it into a pure geothermal well, remediate the soil around it, build the necessary infrastructure, and identify suitable customers. The customer only pays a flat lease rate for the heated, what we call greenfrastructure, that is for the heat and the infrastructure he needs. So in essence, we are real estate project developers. We provide managed agricultural assets, a new asset class, at least for Central Europe. Our beachhead market are agricultural processes that ideally use mild heat, as we call it, for most of the year. So it's aquaculture, fermentation, irrigation, insect protein, heating greenhouses, and drying. Those are the kind of applications where you don't need too high temperatures, but have got the need for those temperatures around the year. So our focus at Greenwell is on compact greenhouses, aquacultures, and aquaponics. Due to the limited geothermal energy output from a depleted well, it is not really suitable for large-scale greenhouses. The competing solutions require much more investment, and Greenwell offers competitive operating costs. In addition, it's the most environment-friendly and sustainable method for heating. As the majority of cost is for the conversion of the well at the beginning, and as there are no substantial operating costs, we can provide the customer with a fixed price for the heated infrastructure. This relieves him from the worries of a fluctuating energy market, especially as we have seen for the last 12 months. Apart from the economic advantages, the upscaling of depleted hydrocarbon wells has also a lot of impact, as it provides sustainable heat, creates jobs in structurally weak areas, and has overall a very positive effect on the environment. We contribute primarily to the Sustainable Development Goal 7 and significantly to the Sustainable Development Goals 9, 11, 12, and 13. Our direct contribution to achieving SDG 7 is that through our geothermal energy and low investment cost for the user, we ensure access to affordable, reliable, sustainable energy. Geothermal energy is renewable, available 24 hours a day, 365 days a year, safe and CO2 free, thus the energy that can power our sustainable future. We also contribute significantly to SDG 9 by providing a heated infrastructure with no capex. We promote sustainable innovations, and we encourage more aspiring agripreneurs to test their early stage ideas in a lean manner. To SDG 11, as our customers will produce farm to table and CO2-free agricultural produce close to urban areas, and so they will contribute to making cities and human settlements inclusive, resilient, and sustainable. We also contribute to SDG 12 by encouraging and supporting agricultural smart foods production like shrimps, microgreens, insect protein, etc. We promote sustainable consumption and production patterns. And last but not least, we also contribute to SDG 13 by harvesting the geothermal heat and reducing transportation. So we do have a direct impact to combat climate change. And now we come to the operational part, which is maybe of more interest to all the petroleum engineers here and those that are already dealing with geothermal activities. I will show you what is going on at Greenwell, what plans we have, but also what we learned so far. Our first pilot well was Rušky Z40 in the Czech Republic. This well was supplied by M&T, who also helped us a lot making this a successful technical pilot project. It's located close to the border to Austria, in the region of Preslav, and not too far away from Hodonín. M&T did the partial plug and abandonment in late 2021, and we took the well over and completed it with steel tubing using special centralizers. On this well, we ran several temperature logs to allow us to calibrate our computer models. We had a test container installed with data transmission to and remote control from Vienna. We used that well mainly to play through different scenarios by varying the pump rate for the circulation and the cooling power, so that we can actually simulate different use cases. This is a picture how the well looked after the partial P&A before we took it over. And this is after the installation of our testing equipment. Sorry, the next slide takes a while. Yeah, that slide actually will show a graphics with the data that were recorded, and as you can see from the time it takes to renew the screen, we really recorded a lot of data in that well. We also varied sampling frequencies. So yeah, we used the data that were recorded, and it's still loading, at least on my side, to calibrate our software model that we have been using to simulate the geothermal potential and the different scenarios. Because of the vast amount of data and our kind of lack of expertise in that respect, we also employed professional data analysts to help us find the right information in the data. The Technical University of Vienna also used the data to advance their simulation software. My apologies that it's not progressing as it should.
Maybe in the meantime, you can answer a question. There was something in
Yes.
the post like, is this a closed loop system or?
Yes, this is the point with depleted wells. We, in our core business model, these are closed loops. So the wells are partially plugged and abandoned so that all the subsurface inflow from the reservoir is shut off, and it becomes basically a deep heat exchanger. So now we've got the picture here with the graph of all the data. As you see, we recorded mainly across the winter season 2021 to 2022. Yeah, and on the left you see a cutout from the casing and tubing. We used special centralizers not only to improve standoff, but also to induce some turbulence into the flow of the water on its way down in the annulus. We are curious to see how these centralizers survived being in the well and the flow once we have pulled the tubing. The next well that we will convert together with M&D will be different, as we aim for a commercial use right from the beginning. With a depth around 3,000 meters, it also has a much higher temperature to allow for a successful application. We are currently modeling the geothermal potential and simulating different use cases. The plan is to start operations later this year. In Upper Austria, we have a different project under development. Here we have no subsurface activities, but we focus on the surface part of our business model. We take the excess heat from a combined production flow and use it to heat the nearby infrastructure for aquaculture and aquaponic projects, as well as for growing exotic fruits. This project will also help us to establish the blueprint with respect to permitting and other administrative issues. As these wells are usually in pasture land, the requirements are somewhat more stringent. For example, you have to have a kind of what they call agricultural engineering expertise in order to get your building permits. In Germany, we are chasing 3 projects. One is already in the pipeline for a few years, but did not make it yet to the execution stage. It's basically a 2-well cascade that would produce enough energy to feed into a district heating scheme. So in the first well, the temperature will be raised from 30 degrees to 39 degrees Celsius. And then it goes down the second well and will be raised to 55 degrees Celsius. The calculations show that the capacity of the total system will provide a power of 380 kilowatts. Unfortunately, there has been recently a change of ownership of the wells. So the company itself is kind of resetting and reorganizing. And also the customer is still wary of the project He wants to feed it into a low temperature district heating. But we hope that in the next couple of months, those hold-ups can be overcome. The other project is a group of wells in an area with a very high geothermal gradient of 7 degrees Celsius per 100 meters. So while the wells are shallow, the energy output would be quite substantial. Currently, the well owner is meeting with stakeholders in that area to introduce his project. Finally, we are eager on our side to investigate recovering the heat from the underground that comes from a steam injection scheme. So that means also that it's at very shallow depths, you have a very high temperature. But as currently most oil and gas companies try to maximize their output, there's not much going on in this project yet. Other project that we have is that in Romania, we're in discussions with an operator to model the geothermal potential of 2 pilot wells in order to use the heat in the production and separation process. In the Netherlands, we are currently scouting land and wells for a German customer who wants to extend his fish farming into Northwest Europe. Besides those projects, we are engaged in a few funding programs. Most important, we just about to kick off the Interreg Transgeo project. This is a partnership across 5 countries, 11 partners with a 2 million budget. And the aim is to develop transnational strategies and regional action plans to repurpose depleted oil and gas wells. We are also participating in a grant program from the Austrian AWS. It's called Green IP, and the aim is to increase the value of environmental technologies and secure them in the long term. We are one of those companies that do not produce lots of patents, and the issue is how can we protect our intellectual property. This might also be then the case in the discussion that I'm not able to disclose everything, because what we learned so far, it's a fine line that we need to walk between giving out information to attract interest, but also keeping our secrets for ourselves. And we are in the process to apply for seed financing from AWS in Austria in a program called Innovative Solutions, where projects that add value to society are funded. With respect to R&D, our focus subsurface is on the tubing isolation. This appears to be the main issue for us. Reuse in hydrocarbons wells for geothermal purposes does not allow for the expensive solutions that have been developed for the oil industry. We need much cheaper solutions and are therefore also cooperating with non-traditional suppliers. We work with the Technical University of Werner to create a simulation software package specifically for our needs. They have already developed the first stage, which allows us to model the geothermal potential. But as our business model foresees many simulations on many wells, we need to kind of automate those processes. And the third area that we're focusing on is the legal framework of mining for geothermal energy, not only in Austria, but also across Europe. This is also part of the Interreg Transgeo project. So what we learned so far is that a successful business model for repurposing existing oil and gas wells is all about finding the right application. This is the key, the right use case for this type of heat. Technically, we see the main challenge downhole, finding a suitable insulation technology. In our process, we need more automation, as I mentioned, in order to speed up the modeling. This can be quite tedious. And if we also want to be successful on a commercialization scale, not just for pilots, we need changes to the existing laws. This affects geothermal energy in general for drilling new wells, but especially also the repurposing of existing wells. There's still this issue of liabilities and transfer of liabilities that need to be solved, and the definition of the geothermal energy within those frameworks. Countries across Europe differ in that respect, Some are easier, like Czech Republic, some are more complicated, like Austria. Overall, the economic framework for repurposing oil and gas wells is very tight. Using the geothermal energy from depleted wells does have advantages, but the revenue potential is limited just by the amount of energy we can generate. Thus, we need to standardize our processes, our technical solutions, and our use cases. So thanks for your attention. Please support our mission. In the next decade, the plan of Greenwell is to convert 1,000 wells across Europe and thus save 1 million tons of CO2. And I'm happy now to answer your question. And I'll ask Akos to assist me in gathering the questions.
Excellent, thank you very much. Great presentation. And it did trigger many questions. So let me start from the top. The first question was, so what is the predicted economic life of your well conversion?
Well, this varies on a project by project basis. It's part of our scouting process for wells that we look at potential well life. So well integrity is certainly a key issue for us. Usually we do the first calculations on a 20 years basis before it either comes to shutting down the well completely or maybe having a need for a workover. The process itself, it's a closed loop system, so the technology involved is quite easy to use, but it really comes back to what is the initial status of the well when we take it over. So we expect that only a small percentage of all wells to be plugged and abandoned can be used for repurposing.
Thank you very much. You mentioned a heat production of 30 to 50 kilowatt per well. That seems to be calculated to be in balance with the natural thermal recharge. Is that correct?
Yeah, I mean, you can obviously a little bit overdraw that. This is part of the modeling we do to see what happens when we've got a higher drawdown, what happens if we stop circulating, how is it replenishing. The amount of the power levels depend really on the setup. We see quite a variation or different flow rates, and key is certainly the insulation, especially in the upper part. The good thing is you can simulate that. The bad thing is it takes time, and that brings me back to this need to kind of automate the simulations where you can define your variables and then run through a series of simulations in an automated way and then just go through the results and not having iterations one after the other.
Thank you. So who pays the abandonment cost for the well in the end?
Yeah, the final abandonment will be on our side. But let's say the big part is certainly the downhole P&A part, shutting off the reservoirs, squeezing off perforations, setting bridge plugs, whatever is required, and obviously the surface remediation that we would kind of also watch carefully. So a key thing certainly is for us to make sure that we get a properly sealed well, properly remediated on surface before we legally take it over. Then it's basically at the end pulling the tubing, the last sort of completion, and filling up the well to do the last couple of meters in line with the local requirements.
I see, thank you. There was another question saying generally geothermal wells have to be about 2,000 meters apart. Could this be much less depending on the direction of the fractures being created? And then let me continue, because there was also an answer or a comment to it from Eva. I believe this is a closed loop system with fluid circulation only inside of the well. it's kind of a heat exchanger. In this case, the distance of wells is not significant. So maybe you can comment.
Yeah, right. Obviously, I mean, you do create a kind of temperature funnel in one well, and that radiates out with time. And if you do have more wells within a field or within the vicinity, you will see some effects on the other well. But it's certainly different to a hydrothermal use, where you're actually withdrawing the reservoir fluid. So we only have the heat flow subsurface in that closed loop, but it is something that needs to be taken into account in a larger scale. This adds a level of complication in a simulation. Just the way the model is set up now, this is something we're looking into, how we can expand the simulation package to allow for several wells to be examined at the same time. Currently, we have to look at one well and take those bounding parameters then to the next well and with different starting points and see what is the knockoff effect on the next well.
Thank you very much. Is the circulating fluid used water or something else?
We tend to go with a straight fresh water, just a little bit of corrosion inhibitor to be on the safe side. But again, the key thing is cost. You could use in principle anything, and there might be much better suited fluids. But the economic framework just doesn't allow it. At the beginning, Robert and I thought about more jokingly about using transformer oil. That would have been maybe a nice side business to fill those wells. But obviously you can't really go ahead with that. You wouldn't get any permits. So we're taking the other side, just plain water, a little bit of inhibitor. This is also basically when we've got a longer term feedback from the well Rushke set 40. We plan to do the work over next year and pull the tubing there to see if we can actually identify any corrosion issues, at least on the tubing and so on.
Excellent. And another question about the type of tubing. So what type of tubing do you use? Fiberglass?
Well, we are looking at several options, and the problem is, in general, coming from the oil field, everything that's hanging vertically doesn't insulate that well, with the kind of the carbon fiber tubing being somewhere than the crossover. So everything that isolates better is hard to hang off. So for the first well, which was more to be used to validate our models and calculations, we used plain steel tubing. Obviously, we had a lot of shortcut in the surface area and could not get that temperature out or that much of the bottom hole temperature to surface. We are about to start cooperating with a tubing supplier. That's a combination of steel tubing and polymers. We have been looking into glass fiber tubing. We haven't used it so far. It depends on two things. First is the mechanical properties, the cost. That's an issue, and operations wise. So what we actually want to try both on the next well is using kind of staggered tubing approach, because the insulation is more important the higher up you are in the well bore, which is also where you've got the higher tensions on your tubing string. That's the kind of nasty thing. But the key thing is really to find, I will say, the highest insulation for the lowest cost. And this is really what we need to test on the next couple of wells to find something what's suitable. In the simulation, you can use everything you want, but in reality, you do have your limitations, what you can realistically run in the hole, especially with older wells that have got maybe not that nice well passes, where we've got a lot of friction going down, and also have got then depth depending high loads.
I see. Thank you very much. And there were a couple of questions about the software that you're using. So there was one question saying, which software did you use to simulate the geothermal potential? And there was another question asking why you do not use the commercial software which support such implementation, and are there specific needs for the simulators you require for depleted reservoirs not exist in the existing softwares?
Well, we could go to the, let's say, the big service companies and purchase some of their software. We just can't afford that, to be quite open about that. That's one thing, and we don't need most of the capabilities of those softwares. What we are really interested in is the thermal flow from the geological layers, and basically the ones from surface to the bottom. So we went actually back. We have been in discussions with the mining university that had developed something. We just couldn't really get to working terms for us also financially. So we turned then to the technical university in Vienna that had supplied such a simulation software in the past for projects. And they kind of reworked that to suit our needs. And that was one of the points it allowed us to go with our requirements. What are our input variables, and what is really key in that. Thermodynamically, it's not very difficult. So I'm not a software guru, and I'm not a thermodynamics guy. It was anything that includes differential equations is not really my favorite. So we leave that to the university. But they have been quite eager to work with us. They're using that for their students as well. And yeah, they are quite open about helping us develop a more comprehensive package specifically for the upcycling of hydrocarbon wells. Again, it's less about the simulation of one well. It then comes really down to doing that on a larger scale, because we need to go through different use scenarios to understand what is the effect on the surface temperature, on the power output, what circulation rates do we need, and so on. So this is the iterations are the thing where we need some level of automation.
Yep, I see. Thank you very much. Then there was another question. How are you working with the current well owners to provide you with well access? I could anticipate well owners would be keen to remove any future well liabilities, including abandonment and site restoration.
Yeah, this is one of the key issues on the legal side, because in most jurisdictions, you hardly can get rid of your existing liabilities. So if you transfer ownership, you're still stuck with your liability for that. And what happens is that whenever there is any event in the well, it will be a question of whose responsibility is it? Is it coming from the use before conversion, afterwards, and so on? So that's not really attractive to the well owners. And that's one thing, the transfer of liabilities. And the other thing is the relationship with the licensor, which is usually the local government. So you create a three-party contract situation where you also need to have a contract with the government, because in most cases you're still operating in an existing producing field. Even if the well is shut off, you are just subject to the existing jurisdiction. And this is something that addresses the work of the association Geothermal Österreich, but also which is part of the Trans-European project Interreg Transgeo, to identify those obstacles, compare them country by country. For example, in the Czech Republic, you can have a complete transfer of ownership. So once you sell it as an oil company, it's done for you. As I said, in most other countries, it's not this way right now, and this is certainly something that's a hurdle to make that on larger scale. But you know, we hope that there is some movement now. The whole situation around Ukraine, Russia, gas supplies, and so on, shifted the public discussions a little bit away from pure electricity, also to the heat, and therefore also we see more attention to geothermal activities. So we hope that legislation will come our way.
I think it's clear that liability is a key challenge. There's another question: who retains liability during the geothermal operations, Greenwell or the original oil and gas operator?
Well,
what about after the well is abandoned?
In our business model, we would have obviously liability for everything we have. This is something, taking over liabilities from the past is first one thing of the scouting process, making sure you've got the proper well so that you can minimize the risk. Second is about the question of can you ensure that? How can you handle that? We are proposing an approach that has been used for waste disposal, where actually all the companies, and it's a similar model also with the nuclear industry in Germany, where all the companies pay into a public fund, and that fund covers then any liability issues that comes from the previous operation. That would take the liability off our shoulders. Currently, the project we are running right now is that the well ownership remains with the well owner, and we are in then a kind of internal relationship with them. This gives us the liberty to test more and minimizes the risk while we are not really commercial yet. But further on, we would take responsibility, of course, for what we do, and in the ideal world, take over the existing well with everything that comes with it, but also with the rules made for P&A. That's also something that needs to be taken into account.
Thank you. Are you using a one well system too? And what about the produced polluted water? Will it be processed or directly re-injected again in the same well? What is the visibility of such a system?
Well, we are a closed loop system, so we hardly have no excess fluid. This would be only in case of a workover, but then again, it's let's say very benign. Obviously, we would have to test for any contaminations just because it's kind of cleaning the casing side, so we would have to dispose. But this is in that case, it's one well filling, so that's easy to handle. We don't produce anything from the formation. That's the benefit, the advantage of this closed loop system. We avoid a lot of questions like what to do with the produced water. It's a kind of standalone solution. The footprint is minimal. We can't do that. Technically, it can be done really in the core well pad. We only need usually then additional land for the use case, basically for the application where the heat is going.
Thank you. Is the permits process in European Union complicated and homogeneous among the different countries?
So as far as we understand, not really. We looked at a couple of countries already. We had early last year, we had a university research project with the University of Edinburgh, where they looked to a couple of countries that are not subject of the Interreg Transgeo project. And for example, France, they have got a quite positive change to the mining laws that makes it relatively easy to take on geothermal projects, versus Austria. where there are still hurdles to overcome. So it's certainly not consistent. You have got a kind of common core of understanding of mining laws across Europe, but the degree of how much they moved on to renewable energy, to geothermal energy, that is varying. And again, this is where we hope that this TransGeo project will help not only identifying this, but also highlighting it to political stakeholders. The project is led by the Helmholtz Institute, Geoforschungszentrum Potsdam, so a very well-renowned research institution that a lot of people, at least in Germany, listen to. And that's obviously a different story compared to when we highlight any things we don't like.
Let me ask another question, which is kind of a follow-up on the previous one. Is it allowed by the EU legislative to use oil and gas wells for geothermal purposes after the expiring oil and gas licenses?
Well, I didn't get the beginning of the question.
Is it allowed by the European Union legislative to use oil and gas wells for geothermal purposes after the expiring oil and gas licenses?
Well, so far it's local law, so country by country. Actually, once the oil and gas production is finished, it becomes easier. So that's the tricky part with the upcycling of depleted oil and gas wells, because you start with single wells. You hardly take over a complete field. So you are within the producing area and thus subject to the current law that affects the production and or exploration. It is easier with dry wells where you don't have a production license. And it's also easier with fields that are depleted completely and where the production license has ended, because then it's considered like any other well. It's just not, the complication comes from being an oil or gas well, even if it has been converted into a closed loop system, because there are other wells around, it makes things complicated. But that's a country by country thing. It's not yet governed by EU legislation.
Yeah, thank you very much. Then let me group a couple of questions. It's mainly about effective insulation. So what concepts are you looking at for cost-effective insulations? Are you looking at using vacuum insulated tubing? And then there was also a comment, I assume that low-profile vacuum insulated tubing is too expensive. Have you thought about low-pressure gas-filled annuals with insulated centralizers? Both have been used in Canada to reduce hydrate and sulfur deposits near surface. When all else failed, we found that geled oil packer fluids were quite cost-effective to cut down convection currents.
Well, the main issue is price, and that effectively excludes vacuum isolated tubing, in addition to technical problems like the vacuum, losing the vacuum with time. We just can't afford that. We're looking into some of the oil-filled solutions, especially, let's say, again, we looking into splitting the tubing string in different segments. We're trying to minimize the cost. There is a Canadian company that coats tubing with an insulation with a quite abrasion resistant, but that's costly again. So our focus is more on going outside. We had started a kind of challenge through the Wirtschaftsagentur in Vienna. They have got a format where you can pose a question that's thrown out to their community, where you get quite some input outside of the box about coatings and so on. Because again, the challenge is you've got abrasion as well, you've got your tensile loads on the tubing, and that doesn't really fit with those materials that isolate well. So we are looking also into using plain HDPE tubing, where we don't have tension issues. So there you've got more the issue of how do you run it downhole. One thing that has been used successfully in the past is tubing and tubing, just without any special insulation in between, just using the original air, not even using then a separate fluid. That is one issue with that, and that's the dimensional properties. One drawback of depleted wells that we are seeing right now, obviously it's the older wells that are depleted, and lots of them just don't have the casing diameters, especially in the lower parts, but a lot of them are completed in 5 and 5.5 inch casings, and you just can't run those larger size tubings in, so you need to have an eye on that. So yeah, this is the key thing we are focusing on with research, and need more time to really come up. We don't have a silver bullet found yet. We hope that corporations with tubing supplier help us on that, because at the end this is the most expensive part of the conversion of the well.
I see. Thank you very much. I see many more great questions, but we have only have 4 minutes left from the original planned time frame. But let me continue. So yeah, sorry, I just said I was dropped out for a minute. So the question was, does the economic model include a percentage being paid to the operator during the geothermal phase? Is the cost of the P&A retained by the operator, or is there an agreed split between the operator and the geothermal company?
We'll start with the first part. No, we would not pay anything to the well owner. This is right now with the legal framework, the incentive to the oil company is not that big. It's one, getting rid maybe of the risk of the final P&A at least, delaying that, getting that out of the books. Certainly there is a, let's call it simply a greenwashing effect. It's also about the social license to operate, which we think will become more important if you can sell basically new projects with the outlook that it's not only for oil and gas production, but it will have a second life as a geothermal energy source. But the business model is that we that the P&A work downhole is done by the oil company on their account, and we basically take over the well once it's a shut off well, and we then also take over what's left on the accrual. That's always the big question mark. Again, this is part of the project scouting. How much has been accrued? Is there a big deficit, or is there a chance that there's something left over that we can take with us? But no, our aim is to have a complete change of ownership and relieve the well owner of all his duties.
Werner, let me answer. Would you have a couple more minutes and we can handle the remaining question? Perfect. Is there a risk of inorganic scale precipitation? Have you evaluated the risk?
We have not really done detailed work on that. Based on the experiences we have, we don't see an issue. I think I guess the question is also coming more from a hydrothermal application. Again, we with the closed loop systems, we do have a lot of flow over time. So it's more about scale removal, I would say, but that's depending on the flow rates and the velocities in the annulus. Rather than this, we don't see any. There's certainly no precipitation from the fluid itself that we use. So it's more about interaction with the casing inside. Again, what's been the status of the well before we take over.
I see. What is the expected lifetime of your installation? If there is a downhole failure, can it be changed rigorously?
Yeah, the downhole installation, the completion part is simple. It's just it's really in the simplest way, it's just hanging off tubing. The question is more what kind of tubing, and do we need something like, if we have staged tubing, for example, do we have a tubing hanger that needs to be considered, those things. But in a very plain forward scenario, it's just removing wellhead, the hanger, and pull the tubing, remove it. So that's a very simple operation. You are working in a already closed system, already filled with water. One of the biggest concern would be if we start leaking. So if the water level drops, certainly something is going on that would require a more rigorous workover. But other than this, where we're staying in a closed system, we are not introducing oxygen into that system. So part of the setup, you would always have to ensure a complete fluid flow. So that's not really something that bothers us even in the longer term.
Clear. Thank you very much. Another question: have you looked at downhole heat exchangers to boost efficiency? And could you share any observations regarding economical pump input power, meaning like smaller tubing could give higher velocity, less temperature loss, but will require more horsepower to counter fluid friction? Also, did you look into fluid friction reducers like small addition of PAA?
We haven't tried it so far. Going back first on the downhole heat exchanger, no, it's something we are not foreseeing. Also, one of the reasons being just because the well geometry is tight in most cases. Second, also again the cost. We see the niche in our system of being straightforward, low cost conversion. Because you are definitely limited by the heat flow, and everybody knows that this is a different story between a hydrothermal and a petrothermal application. We are limited to the heat flow, thus the power will always be limited. We're always talking about kilowatts, and we will be happy if we come above 100 kilowatts, 200 kilowatts in that range. That's already a very good well. We are certainly not getting into a megawatt scenario with the depleted oil and gas well in a closed loop scenario. So we must find the right applications for that can use the maximum from that power. That's the key. I mean, the key is utilization, making sure we've got a use case that needs the temperature ideally all year round. So in the beginning, thoughts were about kickstarting the harvest of asparagus, also plain heating. No, that's not really working because your season is just too limited. We are, like as I mentioned that one time, we're real estate development scheme basically. So we've got a high initial cost, which we need to amortize over time. The operating costs are neglectable, and that comes to the second question, pumping cost. So far, we have used electricity from the grid, but obviously this is something where we are looking forward is to using renewable energy and going maybe into local photovoltaics with battery systems to power that pump. The good thing about our business model is you can calculate everything up front and then decide if this is really an economic project or not. You just need to make sure you do all the simulation that you can imagine. But we can model different flow rates, and the resulting pressure losses, which is a function of the geometry. So far, our let's say basic approaches have low velocity in the annulus and high velocity in the tubing. So you do have the heat working with us, helping us lift the warm fluid. So the pressure losses are manageable, and yeah, but it can be calculated again. It depends then what's your focus. Are you looking more into high power, or do you also need temperatures? What's in again, this is a trade-off that you need to simulate, and depending on the use case, what's better, trying to get the highest temperature on surface, or just have a quick turnaround and increase your power level.
Yep. Thank you very much.
But again, if you're asking for percentages, it depends. I mean, the pump itself is usually in the single kilowatt range. So the higher the output, the more neglectable it becomes.
We have a question from Tim Lyons. Is it always clear who owns the heat energy? Do you pay royalties at the same rate as the oil and gas, or a different tax system?
Yeah, that's the interesting thing so far. And we probably have to say so far, because politicians are always very innovative if it comes to new taxes. So far, heat is basically for free. At least in the jurisdictions we've been looking into, there's nowhere somebody asking for money for the heat itself. Would be very far-reaching discussion about geothermal energy, who owns it, because where is it coming from, right? So it's maybe not as local as oil and gas, which is also far spread. In our case, we have nobody to pay royalty for the heat itself. That makes it attractive, because we can build them a nice package for the customer at fixed rates, because we need to more look at the competitive level to separate us from his alternatives from the competitive energy sources.
Thank you very much. And then we have another question saying, would it be possible to have a jointly founded bond to cover and cap each of the stakeholders' future liability, including the government that owns the right to both the oil and gas and heat? Yeah,
this is actually what I mentioned a while ago. This is would be our target. We think this is a suitable solution. That's a good point. It has already been done in different industries, especially in Austria. I think it was in the 1980s or so. There were big issues with waste disposal sites that had been abandoned. The owner went bankrupt, and the question was, okay, who's going to pay for the cleanup? And as a consequence, they established a kind of public fund that everybody needs to pay into. And that would kind of also transfer, for example, like rules for P&A, and then just having a contribution by each well owner, past and current and future, to pay into a fund that then covers the risk and the liability. This is certainly something that's for this low revenue economic model that we are looking at. Liability can become neck breaking, obviously.
Thank you very much. And with this, actually, we reached the end of the long list of questions. So thank you very much. Thanks for the questions. So thank you, Werner, for your presentation and time. We really appreciate your efforts to support the SP International and also to share knowledge within the SP community. So thanks for your participation and also for our participants. So please follow all the organizer sections on social media and watch out for the next special geothermal talks. So hope you have enjoyed our webinar. Wish you a good day, and thanks for your participation.
Thank you also from my side, it was a pleasure, and hopefully everybody stays in line with that topic and supports us in the future.
Thank
Bye.
you very much. And we wish you a good night.
Thank you.